Look at the back of your left hand. Now, point it north. Go on, commit. No phone, no compass, just your best guess. You almost certainly missed by 30 degrees or more, and you are standing in a heated room with street signs outside the window. Now, put a man in Central Australia, 400 kilometers from where he was born, walking through spinifex in 40-degree heat, and he can name the direction of a waterhole he has never personally seen. His grandfather described it in a song. He gets there. That happened repeatedly for thousands of years across every continent people reached. Humans crossed open ocean, tundra and desert with no maps, no writing, no instruments, and came home. The answer runs through a beeswax pattern on a stick, a woman's brain scan in Iceland, the sun's position at dawn, and a chain of song verses that doubles as a route. Start with what we actually have in our hands, which is almost nothing. Wood rots, bark rots, memory dies with the person carrying it. So the archaeology of navigation is mostly a hole where the evidence should be, and the few objects that survived are strange enough to look like jewelry until somebody reads them properly. The Marshall Islands stick charts are the clearest case. Islanders in the Central Pacific lashed together palm ribs and cowrie shells into flat frameworks, and for a long while Western collectors filed them as decorative art. They are not maps of islands. The curved ribs represent the way ocean swells bend and refract as they wrap around land, which is a thing you feel in the hull, not something you see. The shells mark the islands. The sticks mark the water's behavior. Here is the part that breaks the museum label version. The charts were not carried in the canoe. They were learning aids, memorized on shore, then left behind. The navigator went out with the pattern inside his head, lay down in the hull, and read the swells through his own spine, which means the most sophisticated navigation instrument ever built on those islands was a man's lower back. That sounds like poetry until you look at what a body can actually detect. In the Pacific tradition, documented most closely by the anthropologist and sailor David Lewis in the 1960s and 70s, the master navigators of the Caroline Islands worked with a set of swells arriving from different distant storm systems, holding steady direction for days on end. A navigator who knew the dominant swell could hold a heading through a night with no stars at all by the rhythm of the pitch under him. Lewis sailed with these men. Mau Piailug, from the tiny island of Satawal, later steered a double-hulled canoe from Hawaii to Tahiti in 1976, roughly 4,000 kilometers, without instruments, and hit his target. That voyage is the reason this knowledge is not entirely gone. But swells only get you a bearing. They do not tell you when to stop. And the ocean around a low coral atoll is empty for hundreds of kilometers, with the island itself invisible below the horizon until you are almost on top of it. So how do you find a target you cannot see in a desert of water, with a margin of error measured in a few kilometers? You widen the island. That is the actual technique, and it is the most elegant thing in this entire story. A Pacific navigator did not aim at land. He aimed at the halo around land, the zone of signs that a small island throws outward across the water for 50 or 60 kilometers in every direction. Terns and noddies fly out to fish at dawn and return to their nesting island at dusk, so the direction of an evening flight is a bearing. Certain cloud formations sit still, while other clouds move, because they are stacked over warm land. A green tint on the underside of a cloud is shallow lagoon water reflected upward. Suddenly a target 3 kilometers wide behaves like a target 120 kilometers wide. Your allowable error jumps by a factor of 40. Compare that to how you navigate now. You follow a blue line and a voice, and you arrive at the exact doorway, and you learn nothing about the neighborhood. You have accuracy without any halo at all, which is why you can drive to a house 6 times and still not know which way the river runs. And this whole system assumes a sky you can read. Take the sky away and something even older comes out. Fog, overcast, 6 weeks of North Atlantic cloud. The Norse sailed anyway. and the way they may have done it involves a rock. Icelandic sagas mention something called solarstein, a sunstone. For decades, that was treated as a story. Then physicists, notably Guy Ropars and colleagues at the University of Rennes, started testing calcite crystals Iceland's spar and showed that a crystal like that splits light according to its polarization, and that a trained user can rotate it until two images balance and read the direction of the hidden sun through cloud to within a few degrees. I want to be honest about the status of this. No sunstone has ever been found in a confirmed Viking navigational context. The clearest candidate is a calcite crystal recovered from an Elizabethan shipwreck off Alderney, dated around 1592, which is the wrong century and the wrong people. So the sunstone remains a physically demonstrated possibility with a hole where the artifact should be, which leaves the interesting question wide open. If Norse crews had no crystal, what were they using instead, and why did they keep arriving? The unglamorous answer is that they were reading the sky's polarization with their eyes, and the water with everything else. Norse practice, as reconstructed from sailing directions in later Icelandic manuscripts, leaned on latitude sailing. Get to the correct latitude by the height of the sun at noon, then run straight along it, east or west, until land appears. It is crude, robust, and forgiving of cloud. The forgiving part matters, because the Norse target was not small. Greenland's east coast is over 1,000 kilometers of ice-choked shoreline. Miss by 100 kilometers, and you still find Greenland. And they had living instruments. The sagas describe releasing ravens to find land, which is exactly the aimed at the halo trick again, using a bird's eyesight instead of your own. There is also the smell of it, which no one puts in textbooks. A crew downwind of a Greenland fjord in summer smells sheep, meltwater, rot. Your nose still does this. You know your own street by smell without ever having decided to learn it. Now, shift to land and to the single most complete navigation system anyone has documented, which was running long before anyone in Europe was writing anything down. Across Aboriginal Australia, routes were carried in song. The verses of a songline follow the order of features along a path: a rock, a soakage, a bend, a claypan. So the sequence of the melody is the sequence of the country. Sing the verses in order, and you get the landmarks in order. Sing them backwards, and you get the way home. The scale of this is what people underestimate. Individual song cycles are documented crossing many hundreds of kilometers and passing through the territories of several language groups, with sections handed over at boundaries like relay legs, each group holding and being responsible for its own stretch. There is a further claim on the record that goes much further, and it is contested rather than settled. The linguist Nicholas Reed and the geographer Patrick Nunn have argued that Aboriginal accounts of coastlines drowning by rising sea correspond to real events at the end of the last glacial period, which would make some of that oral information around 7,000 years old and possibly older. Not everyone accepts that dating. It is a reading of stories against a sea level curve, not a carbon date. But even the cautious version leaves you with a route description that outlived every empire in Europe. Here is where it stops being history and starts being about the machinery in your skull, because none of this works without a very specific kind of memory, and you have it. Follow a rat through a maze with electrodes in its hippocampus, and you find cells that fire only when the animal is in one particular spot. John O'Keefe found those place cells in 1971. In 2005, the Norwegian team of May Britt and Edvard Moser found grid cells in the entorhinal cortex, firing in a repeating triangular lattice across space, effectively a coordinate mesh. That work took the Nobel Prize in 2014. Humans have the same hardware, and the size of it moves with use. Eleanor Maguire's imaging studies of London taxi drivers, published in 2000, found enlarged posterior hippocampi in drivers who had passed the knowledge that brutal exam, requiring roughly 25,000 streets held in one head, and a follow-up tracked the growth happening across. Training. So the hardware grows when you make it work. What does it do when you stop? Nothing dramatic. That is the problem. It just gets quieter. Here is the small indignity of my own version of this. I have lived on the same street for years. I once tried to draw the route from my flat to the nearest supermarket from memory and produce something that looked like a diagram of an intestine. I have walked it more than 400 times. My phone knows it perfectly. That is not a moral failing. It is the same trade every technology makes. What is worth noticing is the specific thing being traded away, because it is not sense of direction as a vague skill. It is a physical structure with a measurable size. Veronique Bobot's lab at McGill has run this comparison for years, and her work distinguishes two strategies: spatial navigation, which builds a mental map with landmarks and relationships, and stimulus response navigation, which memorizes turn-by-turn instructions. GPS use pushes you hard toward the second. In her studies, older adults who used spatial strategies showed greater hippocampal gray matter than habitual response strategy users. A 2020 study by Louisa Dahmani and Bobo reported that heavier lifetime GPS use was associated with worse spatial memory when people were tested without it. Correlation, not proven cause. The honest reading is that we do not yet know which direction the arrow points. Turn back to the song line for a second, because there is a detail in it I have been holding. The verses were not just a list of places. They carried what happened at each one, who was responsible for it, what could be taken there, and what could not. A route description that was simultaneously a law code, a genealogy, and a water inventory, which explains something odd about human memory. We are terrible at remembering abstract lists and excellent at remembering journeys. Memory competitors exploit this deliberately with the method of loci, walking an imagined route and hanging items on it. That trick is at least as old as the Roman rhetoricians who described it, and it works because the machinery was never built for lists. It was built for the walk, which brings us back to that beeswax and palm rib framework left on the beach in the Marshall Islands, because it now looks like the strangest object in this story. Every instrument we have built since points the same direction: outward, sextant, compass, satellite. Read the world, print the answer, hand it over. The stick chart did the opposite. It was a device for loading a pattern into a person and then being thrown away, and its only output was a man who no longer needed it. The knowledge lived in the swell against his ribs, and when he died it was gone, unless he had already sung it into somebody else. That is the part we cannot get back. Not the technique you can still learn to read swells at Satawal, barely. What is gone is the arrangement where the map had to live inside a body. So the body had to stay valuable. So the old man who had made the crossing 40 times was the most important object on the boat. You are carrying that same equipment right now. Grid cells in your entorhinal cortex, firing in a triangular lattice, ready to build a coordinate mesh of anywhere you walk. Hardware that grew in London taxi drivers when they held 25,000 streets in their heads. It is running while you sit in traffic, following a blue line to a doorway you will not remember. Somewhere out past the horizon, the terns are still flying home at dusk, drawing a bearing across the water that nobody on the boat is watching for anymore.